So this time we are asked to solve an exercise where a bank is quoting an annual nominal interest rate of 7% with quarterly compounding. And we are asked what is the equivalent rate with continuous compounding. So again, the nominal rate is 7%. And the compounding frequency is 4 because there are 4 quarters in a year. So our quarterly rate, which we will denote as RQ, is going to be equal to 7% over 4, or 0.07 over 4. And what we need to find is the equivalent continuous rate. Which I will denote as RC. This is our unknown. The formula we already know is 1 plus R F to the power of F. And we want to set it equal to 1 plus RQ to the power of 4. However, what's interesting here is that the compounding frequency tends to infinity because we are compounding at every instant. So what we can say is that we are looking for the limit as f approaches positive infinity of this expression, so 1 plus RC over F to the power of F, and set this expression equal to 1 plus RQ to the power of 4. Now, we will not prove this, but we know that this expression can be rewritten as e to the power of RC, which is pretty convenient. And so we know that e to the power of RC is again equal to 1 plus RQ to the power of 4. And again, we want to solve for RC, and what we can do to isolate RC is to take the natural logarithm on both sides, so that we have RC on the left side and the ln of 1 plus RQ to the power of 4, and by the property of logarithms we know that the ln of a to the power of b can be rewritten as b times the ln of a, which in our case is going to be 4 times the natural logarithm of 1 plus RQ, which is also, we can plug in the numbers. That's going to be equal to 1 plus 0.07 divided by 4. And that is our equivalent continuous rate.